So the opportunity for us here actually is to say when this application starts, we want it to start with a much bigger number of buckets for our string pool. Remember, this doesn't get resized unlike a regular hash map. So whatever number we start with is going to be the number for the length of our application. So we're going to put a flag in which is going to change this. Just before we do, notice that the total footprint of our string pool is just over 800 megabytes. We might want to just remember that figure. So the flag, and I'm going to recall my last command here, and then we'll add in this flag. We'll still print out these string table statistics, but we're also going to put in another flag, which is -XX:, and it's called string table size. And we set that equal to a number. How many buckets do we want our string pool to be? Well, for this to work in an optimal way, the number that you provide in here should be a prime number. So we want a prime number that is bigger than 60,013. Now, actually, I've gone off and checked, and the next prime number that I can find that is bigger than at least double 60,013 turns out to be 120,121. I actually used the code that we saw earlier in the course when we were experimenting with prime numbers to come up with that number. But that should work. That should give us a string table that's double the size. It should be efficient because it's a prime number. Let's run it and see what happened. So remember that the last time we ran this, it took 49 seconds and the maximum bucket size was 196 with an average of 166. I'm going to press enter. Once again, it'll take a little while, so I'll pause whilst this runs and then resume recording when it's finished. Okay, well, that has just finished. The elapsed time has gone down. I'm going to try and get both sets of figures on screen here, from 49 seconds to 28 seconds. Again, this isn't that scientific, but that is definitely significant. We have definitely here made an improvement in the way our application runs. If we look at the density of our string pool, the average bucket size is now 83. So on average, a bucket has 83 different strings in it. It was previously double that. Well, that's what we would expect because we've doubled the size of the string pool. The maximum bucket size actually isn't that much lower. It's gone down from 196 to 157, but clearly our string pool is less dense. We've made it more efficient. We've improved the operation of our application. And notice that the total footprint of the string pool, which is now 800.9 megabytes, well, that's only gone up a very small bit. It's half a megabyte. So we've not dramatically increase the amount of memory required to increase our string pool to this extent. Now, this was an extreme example. We'd probably want to experiment and make the string pool even bigger in this example. That is, as I said, extreme. In your applications, I would certainly look at these string table statistics, and as a rough guidance, if the average bucket size is, I would have thought, around about 40 to 50 or more, it may well be worth playing with the number of buckets in the way that we have just done.